Welcome to web development for non-developers or not yet developers. This is a talk about the basics of web development for those who aren't already in it, or for those who are maybe trying to get into it. I used to be a teacher at a coding boot camp, and I frequently gave a talk to people about what web development was like, what being a programmer was like, and things like that. This is the screencast version of that talk. This is for people who are interested in becoming developers. This is for people who are just around developers a lot and just want to understand things more. Think of just interested people who do lots of stuff on the web and go, I really want to understand this more. Or like product owners or people that work at companies who work with developers and want to understand the terms a little bit better. This is for that group of people, the generally interested for curiosity's sake or maybe even for professional sake. So that's what all of this is about. Now, when I used to do this, it was live. And since it was live, I was able to take questions. Well, I can't really do that because this is a screencast. So what I'm going to do is if people leave comments with questions, I can do another follow-up video later to answer those. So feel free to do that when this is over. But for now, let's get started. And so what we're going to be talking about is coding, sort of. And I say sort of because this is code. We're not really going to be talking through code. We're going to be talking about what code does. This is JavaScript, one of the languages we'll be talking about. We're here to get the big picture. We can't really get into the details of code and whatnot. This is conceptual. This is going to be lots of drawings and lots of discussion, not programming details. Usually what I would do when I would give this talk live is I would take a list of just random technologies and terms that people would come up with. And they're like, hey, okay, I've heard about C++, I've heard about React, Angular, what are these things? And so here's a list I came up with. Some of these are drawn from former versions of this talk. Some of these are just drawn from popular technologies. Some of these are from coding boot camps. I went and looked at some curriculums to see, okay, what are they saying they're going to teach? That's what all of these come from. And I've taken the liberty to arrange these a bit. So we have languages, backend stuff, front-end stuff, and I'm going to explain how all of this works. That's where all of these terms come from. Now, what we're going to be going through is important technologies, terms, but also to get a better picture of the internet, because to understand all these things, we're going to have to start there and talk about that a little bit. And so perhaps this will be helpful for you as well, because it's something we use all the time, and it's good to understand it a bit better if we use it. So let's get started. Okay, so let's say you have a computer. Here's your desktop computer, and it's got a monitor. Okay, boom. Now we know there's this internet thing out there, and then we know on the other side of that there's something like Amazon. So let's say Amazon is running on a computer. What we do is we open up our browser and we say Amazon.com, and somehow that goes to here, and then this goes to Amazon, and magic happens. All right? Well, let's dispel a little bit of this magic, because understanding this a little bit better will definitely help you understand the difference between front end and back end, which is one of those big distinctions that come up when people talk about programming. So let's get rid of this big cloud, because the cloud has ideas of amorphous, cloudy, I can't see it, what is it? Let's get rid of some of this stuff. So whenever you are, once again, let's go back to you in your browser, you are typing in Amazon.com into your browser. So what happens? Well, let's start with this notion. First of all, your computer is connected to some sort of router in your home, right? Some sort of router in your home, and that is connected to something. What is that connected to? That's connected to some sort of networking device. Now, we would ask, is this networking device connected directly to Amazon.com's computers? And the answer is no. The reality is there is a whole bunch of computers and different networking devices that are scattered. These are physical devices sitting all over the place, and they are interconnected. So whenever you put Amazon.com in your browser, what's really happening is all of these requests to see the page are bouncing around from computer to computer to ultimately get to Amazon.com. You might go through 10 computers. You could go through 100 different networking devices in the internet to get between your browser and what is at Amazon.com. That's normal. That's actually how this whole thing works. So that's what the internet is physically made up of. It's wires, it's computers, it's networking devices, and so forth. And so you put in your browser Amazon.com, and then it goes and gets stuff. Now let's back up a little bit. Let's go up here and look at some terms. So I want to look at this random stuff category. What have we talked about so far? Well, the internet is a network. It is a bunch of different devices that are connected to each other. You probably knew this. That's the network. I want to talk about DNS now, because DNS is also super important. So let's say, once again, you want to go to Amazon.com. Now, Amazon.com is not a bit of code sitting on a single computer somewhere that every other computer in the world knows how to get to. Doesn't work that way. Out here on the internet, there's some specialized networking devices, specialized computers. And what they do is they do DNS. They do domain name resolution. And so when you put in Amazon.com, what happens is this request will first need to figure out, wait a minute, what in the world is Amazon.com and where is it? Because computers don't come prepackaged with all of the website names in the world, and more are being created all the time anyway. And so what happens is it goes out and it hits these DNS servers, and it says, hey, I want to go to Amazon.com. Please tell me where that is. And so what happens is the DNS server responds back to your computer, and at that point it knows where it is. One thing that we can now see about this whole internet thing is it's built on this idea of request and response. When we want to know how to get to Amazon.com, we send a request out, and that's going to be satisfied by the DNS system on the internet. That will tell you, hey, here's where it is. Well, that's a request and then a response. When you go to Amazon at that point, now that you know the actual address, and we go back to that first line we were talking about, what happens is it gets a request and then it sends back a response. Which may or may not take the same route over the internet to get back to your computer. So everything is based on this request response. This is why sometimes it can take a little bit of time, because you send a request, it has to jump around various places. It gets to this computer or this server that is running a website. It has to do something, and then it has to give back a response, and then that goes back across the internet. That's one reason why the internet can be slow. It could be because the stuff in the middle is slow. It could be because the computer on the other end, the server, is slow. Who knows? It could actually be in a number of different places. This is essentially a very, very rough sketch of how the internet works. Now, I want to draw a line. Right here. When we talk about technologies, when we talk about the front end, this is what we're talking about. This is code that's actually running over on this side of that division. Where's the back end? If you hear about back-end development or just back-end developers, where are they working? They're working on this left side. They're working with the server and writing code that's actually running over there or behind there. Front-end development and back-end development, they're actually different than the internet itself. The internet is the glue that holds it all together. But when you're doing front-end development, you're really writing code that's running on some computer. Maybe that's a phone, maybe that's a desktop or a laptop, but it's code that's running on some computer over in your house. Back-end code over on the left side. This is on the server. Now, programming for both of them shares a lot of, she really shares a lot of characteristics. It's all about code either way. It's all about this kind of stuff. What you have to do is often very different, but often you can use the same exact languages on both sides. The problems they tend to solve are very different though, because on the front end, you're building user interfaces. On the back end, you're building like database logic, how to store data, how to effectively retrieve it, and whatnot. So that's front end versus back end, and that's how it fits here on the internet. So let's mark DNS out at this point. And now let's jump in. Now that we've introduced front end and back end, let's jump in a little bit more. I want to make a distinction between programming languages and toolkits that you would use to do things. So programming languages are very generic. They are general purpose, generally speaking. They are general purpose. Some of them are more specific than others, like for example, SQL, which we'll get to. But think of them as general ways of expressing what you want, because programming is all about telling computers what you want them to do. That's the purpose of the languages. Then there's back-end frameworks. Here's some really common ones that you'll see in various job postings, whatnot. ASP.NET, Django, Rails, that's this stuff over here, these back-end frameworks. These back-end frameworks work with or are used with the languages above, right up here. They're used with those languages above there, and they are meant to make things easier to do on the back-end side of programming. Just think of them as toolkits. Think of them as, maybe you don't want to write everything from scratch, so you can use these because they give you common things for you to use, common tools to solve problems. Those are the back-end frameworks. If we think about front-end web UI, it's very similar. Now these two, HTML and CSS, maybe should belong over in languages, maybe not. I guess it depends on the way you look at it. They're for building user interfaces. Now, HTML and CSS up at the top, these are special. Out of this list, these are very special because these very popular, what are called libraries or frameworks, okay, React, Angular, Vue, or older than these, jQuery, these are all built on top of and are meant to create and manage HTML and CSS. But all of this right here, all of this is for building a user interface that runs in a web browser on your phone or on your desktop. Mobile UI, think of using your iPhone. That is really more like the front-end web UI in terms of what it's doing. It's building iPhone apps, it's building Android apps and whatnot. And we'll get to that a little bit later. So front end, think it's building user interfaces. Back end, think it's saving data. It's pulling data from the database and whatnot. So now let's talk about that Amazon thing again. So you've made your request to go to Amazon. What's going on when that happens? Not during the request, but after the request is over. I'm just going to give you a hypothetical here, because I don't work at Amazon, so I can't tell you exactly how it works behind there. But basically, I mean, all backend systems have some simple ideas. So here's the internet. Here's the request coming in. Amazon doesn't have a server. Amazon has thousands of servers. And so whenever that request comes in, it's going to go to one of those many thousands of servers that it can hit. Now, when you go to Amazon, it's not just a user interface, right? When you go to Amazon, it's got lots of data. It's not just a pretty thing you can look at. It's got all sorts of books. It's got all sorts of clothing. It's got all sorts of whatever. Now, if this is your first time to Amazon, well, honestly, I don't even know what that's like, because I've been to Amazon for years. But basically, you're going to get some sort of data. They're going to try to sell you some things, but they don't really know anything about you if this is your first time there. So what's going to happen? Let's just pretend it's your first time there. And so the request comes into the server. The server sees this request and says, okay, somebody wants the home page of Amazon.com. So somebody then wrote some code, all right? Some code. A request has come in for Amazon.com. I don't have a clue who they are. So let's go get some default data. So what that's going to do is it's going to go and it's going to fetch. Here's a common symbol for a database. It's going to go and get some data. All right. Request has gone here. The request is now running some code, or running through some code, or some, I guess you should say that some code is handling the request. That code is running. It goes and gets some data. Maybe it makes a bunch of different database calls. Go gets lots of data together. And then, think of it, data. To what's it going to do? Well, now it's going to take that data and it's going to turn it into HTML, CSS, and JavaScript. So now you've got requests coming in, code handles it, goes, gets data, generates some HTML, and CSS and JavaScript, and then it sends out the response, and then it goes back out to that image that we've seen before. Back over here on the left, there we go. There we go. Back over here on the left, there's a whole lot of things. The back-end world, there's lots of variety to different types of databases and different things you can do here. So this is a very simplistic picture, but this is the basic idea. Request comes in, code takes the request, gets some data, generates HTML and CSS, JavaScript, and then sends it back. Just know that there's this whole big world, and we'll talk a little bit more about it. So back up to this picture. Now the request is going back across the internet and showing up on your computer. If you open up a browser, go to Amazon.com, open up a browser, you probably have done this. If you right click on the page, you can view source and you will see the HTML that they sent to you in the response. You can do this on any web page. You can go see some of this code, some of this HTML that was generated to give you the view that you have. This is one of the interesting things about web development, is you don't already automatically have the user interface for Amazon.com on your computer. You go across the internet, and every time you go to a new web page, you pull down a new copy of that one page of their user interface, copy it and bring it all the way across the internet back to your machine. Your machine takes that code and interprets it and displays it on your computer. Now, this last step of interpreting it and displaying it on your computer, this is why sometimes web pages will look a little bit different if they're viewed on Firefox or Chrome or Safari, because these are different web browsers. And these don't always show everything the same exact way because it's different code, at least somewhat, underlying all of them. Because that's the case, a website might actually look a little bit different on one computer or one browser versus another. Anyway, that's the big picture there. So now let's go back up to backend. So let's take an example. Let's just pretend Amazon.com was written in PHP. So what you could do is you could say, all right, we're going to build it in PHP. Facebook, for example, was written in PHP. We're going to build it in PHP, and instead of just using raw PHP, we're going to use Laravel, because Laravel is a PHP framework. And so the developer would be working with a language, PHP, and working with a framework, Laravel, all day long, building things, building pages, handling links, letting people submit data, taking that data, putting it in a database. That's what these languages and these backend frameworks do. That's generally their function. Now, something we haven't talked about, which we will be talking about, are different databases. We'll get there in just a second. Or let's say, you know what? Amazon's not written in PHP. Amazon's written in Python. So Python, what would you do? Well, maybe you would use the web framework Django. The reality is, for most websites, and by most, I mean 99.9% of all websites, if you're building a basic back-end website, you're building a website that needs to pull some data and put it on a screen. 99.9% of the time, it really doesn't matter which one you choose. And now I just noticed that Laravel is actually on here twice. Interesting. Anyway, it really doesn't matter which of these you choose. Any of them work. Often, really, the best decision is just, if you have developers, what do they prefer? Oh, they prefer Rails? Okay, well then use Rails. Use Rails and Ruby. It's fine. You could build 99.9% of all websites with that. In some cases, there are there are websites that need extreme performance, and you need to be really picky about what language and framework you want to use. Fine. That's great. Generally speaking, most people, they're not going to work in some sort of context like that. That's the rarity. Generally speaking, pick whatever you want, and anything's going to work. So if you wanted to get into development and you just want to make some stuff for yourself, then just pick one. It doesn't matter. Which also means it's kind of hard to choose, because you're like, well, if all of them work fine, which one do I pick? Well, it doesn't really matter. Maybe choose one that, let's say you have a friend who knows one, you can bug them with questions. Maybe that's how you would choose. But ultimately, it doesn't matter. Choice for backend frameworks and languages and frontend frameworks is, generally speaking, just a preference choice for developers. It's really nothing more than that most of the time. That isn't to say that some aren't better than others. In some cases, they are. But ultimately, what it comes down to, and what really drives it more than anything, is preference. So let's go take a look at these languages and talk about preference. Now, some of them are for specific things, or are used more often than not in certain specific circumstances. Like, for example, let's talk about C. Now, C is a very common language, but you don't make websites in C. You're going to use something else. Objective-C, well, that's a C-based language, but it's really used mostly for iPhone or Mac apps. What about C++? Well, C++ is also a C-based language and is used for not web development. You'll see C, Objective-C, you'll see these a lot in operating systems. You'll see C and C++ in hardware devices to build drivers and whatnot for those kind of things. It's not that you can't use them for other things. It's just that's really where they often shine. Now, what languages do people actually use for web development? Well, Java is very common. C# is very common for web development. .NET. What's .NET? Well, C# is a language that works on the .NET platform. You could think of it as a, if this is .NET, all right, this whole thing is .NET, then C# is one language in here, and VB.NET is in there, and F# is in there, and a whole host of other languages. So C# is the most common, as far as I know, last time I checked, it's the most common .NET language, but they are obviously related. But you would use .NET and C# often for web development. That's really common in Dallas, where I live. PHP. PHP can be used for things other than web development, but it was really specifically made for that. And you're not going to find PHP being used for building iPhone apps, for example. This is very, very web development-y. Python is a really great language for web development. Is also used in a lot of cases outside of web development, though, so it's a good general purpose language. Now, JavaScript was a language built to run in the browser on the front end, and so was specifically just for front-end web development. But a number of years ago, that changed, and now lots of people use JavaScript for backend as well, using Node.js. Ruby is a very common one for web development, skipping SQL. TypeScript. TypeScript is common for front-end web development. All right, so front-end, I'll put that here. Front-end web development. TypeScript is something that essentially gets turned into JavaScript by a compiler so it can run in browsers. It's fun. It's interesting. What about Go? Go can be used for web development. What about Swift? It can be, but not very often. This is really mostly used for mobile. And Kotlin is another one that's often used for mobile, for Android apps. Now, some of these are really general purpose languages, like, for example, Java. All right, Java is a good language for doing web development, but it's also good for doing mobile. You can also do mobile development using C#, for example. You can also do mobile development using Ruby. You can do it using C. You can do it using Objective-C. So these languages really can cover a lot of different territory. So if you learn C#, you can actually do some C# on the front end and on the back end and on mobile. And so it's a very versatile language. Some of these have more specific use cases, like, for example, SQL. SQL is a database that specifically, it is a language made specifically for databases. And so if you're talking to one of these things over here on the right, from your backend, you're going to be using SQL to do that conversation. At least you will with some of these things over here. So languages. Think of languages as how you tell a computer what you want it to do. Now, down to toolkits. All of these essentially do the same thing. They just do it, slightly differently, and they're for different languages. But why would you need these? Well, let's go back to here. Now, we went through the scenario of going to Amazon.com for the first time. What about when you go on a subsequent visit to Amazon.com? Let's say you've logged in, and they've been tracking things that you've bought. They're spying on you. Well, they're spying on you because they want to, figure out what you want and show you attractive things so you spend your money. So the diagram actually looks the same here, up here at the top. The difference is this code, right? This code might be doing extremely different things. Because what's going to happen is whenever you come across, there's this thing called a cookie. And here's my attempt to draw a chocolate chip cookie. All right? A cookie, what is a cookie? A cookie is a little piece of information. All right? And so whenever you go to a website, what the website can do is they can put a little piece of data, put it in a cookie, and send it to your browser. And then every time you come back to the website, they'll send that cookie back. So when you log in, for example, when you log into Amazon.com, it's going to see who you are, write some information in the cookie, and send it back to you so that the next time you come, it can look at that cookie when it comes back and go, oh, you're Eric. Okay, I know who you are. And so therefore I can go fetch certain things. And so in our particular example here, I happen to like books, and I buy lots of Greek books. And so my cookie will know who I am, and the request comes in, and the code here goes and like, okay, this is Eric. We know who Eric is, and how do they know that? Well, they look at that cookie, and well, they go to some database. All right, they go to some database, and they go, okay, get me some basic information about Eric. So they get that information. All right, Eric likes Greek books. Okay, well, since Eric likes Greek books, I'm going to get data to show him so I can sell him stuff, and I might get some of his recent purchase data and all that. But it's going to be specific now because I know who you are. So this code, this is what developers do all the time, is they write instructions in code to handle different scenarios and different web pages. You come to this page, you need this bit of data. You go to this other page, you need this other bit of data. You go to this page, and that's where you enter data in. All of these things require somebody to go write some code and think through custom logic. And so that's where backend comes in. The request comes in, you write some code, you go to one or more databases, you collect that data, and then you generate some HTML, some CSS, and JavaScript. You send it back across the internet for somebody to see. And so, backend frameworks. Let's say you need to read a cookie from the request that comes in. You could write all that code yourself to go through that piece of data, that what is called an HTTP request. You can go through and get that data out, or, because that's kind of a pain, you can use ASP.NET and say, hey, ASP.NET, give me this cookie by this name and pull this information out for me. It makes it a lot easier for you. That's what these backend frameworks do. They're toolkits to, I can read cookies. Okay, cool. It's a toolkit to talk to the database. It's a toolkit to hand a request and say, wait a minute, you're not logged in. I have some special code here that makes it easier for people to handle login flows and whatnot. That's what all of these backend frameworks do. Okay, moving back to the front end, what do these do? Well, everything is made up of HTML, CSS, and JavaScript when they go over the web to somebody's computer. What about React, Angular, Vue, and jQuery? Well, as I mentioned earlier, jQuery is older, but still very common. React and Angular and Vue, think of jQuery as a small library of easy-to-use things. Think of Vue and React and Angular as larger libraries of probably not quite as easy-to-use things, but more powerful things. If I just need to make a web page that has a little bit of JavaScript on it that needs to change the page a little bit, let's say when you click a button, hide something, I'll just use regular JavaScript. Maybe I'll use jQuery. I'll probably just use regular JavaScript. But if I'm going to build a very, very complex front-end user interface, then, okay, I'll reach to something like React. I like React a lot. That's my particular choice there. So I'd pull out React and build something. But some people prefer Angular. Some people prefer Vue. Some people prefer others. And so when you're that developer who's working on this side and is building user interfaces to show on people's browsers, you're using HTML and CSS, and sometimes you're using jQuery, React, Angular, Vue, and whatnot. Now, I put this last one in. It's very different than the others, but I put it in because it is related to front-end web development and does come up a lot, and that is responsive web design. What responsive web design is, here's the basic notion. Let's say you have a phone. Here's your iPhone. Wait, they don't have buttons on the bottom anymore. Well, some do. All right. Here's your iPhone. And then you have your laptop. Okay? Here's your laptop. Let's keep on. Now, the iPhone has a very small screen. Androids, they have small screens too, compared to laptops. Laptops have, big old screens here. Wouldn't it be nice if you could write essentially the same code to generate HTML, CSS, and JavaScript on the web, send it over, and have it work on both things, to where you got all this code that you don't want to duplicate all this code and say, I'm going to write all this code for iPhone, I'm going to write all this separate code for desktop, then I'm going to write all the separate code for iPad. No, you want to write one set of code where it works on essentially all devices. That's what responsive web design is all about. And that's really it. Now, back to the internet. Back on the subject of phones. Let's say you were using a phone. Once again, here's your iPhone. And you go to a web page and you go to Amazon.com. What happens? Or you go to an app. You open up the Amazon native app. All right, what happens? Let's talk about the web first. It's actually almost exactly the same. The difference is, unless you're home on your Wi-Fi, what you're going to be doing is you're going to be talking to some cell phone tower. You've got a data connection. Now, if you're on Wi-Fi, talking to your router, it is 100% the same as the other scenario. If it's not, then you've got a data connection, a cellular connection here. This is your data plans for your phones, connected to this. Now, this is connected to the internet. And so if you're making requests from your phone over the internet, it basically works exactly the same. Now, what if, instead of using the web browser, you are using an app on the phone, something that you downloaded from the App Store? Let's say you're using Twitter on there. Okay, what's going on? Well, the Twitter app is actually very different in terms of how content and whatnot gets delivered than web browser. With something like the Twitter app, or with most games, most apps that you would download from the App Store, what happens is there's servers over here on the internet. So let's say here's your Apple App Store servers, and this is connected here. This is connected to here. When you're on your phone, you go to the App Store and you say, download the Twitter app. So that what happens is that request goes out here, from your phone across the internet all the way yada yada to here. And you download that app and it gets installed on your phone. The web, when you go from page to page, you're downloading a new version of that user interface that you're interacting with every time you change pages, unless the developers have gone to some lengths to make it not quite work that way, which is something very common with React and Angular and Vue, for example. But when you just go to most regular web pages, like, for example, when you switch pages on Amazon, generally you're just downloading, every time you change pages, a new user interface each time. What's going on with mobile apps, or if you have a what is called a native app running on the computer here, it's going to work the same way. You download that app, and usually you download the user interface with it. And then what's happening whenever you're communicating across the internet is you're not passing the user interface back and forth, because that was written in Swift, or that was written in Java for Android or something. You're not passing the user interface back and forth. You're not that stuff you see when you view source in your browser. You're just passing data. When you're just passing data, some of this looks a little bit different. The networking stuff, it's exactly the same. When you're just passing data, you're not using a front-end web UI. When you're just passing data, you're still hitting a back-end framework. That's still there, and the instructions are still written in whatever language of choice you've chosen. But when you're just passing data around, what we're generally talking about is APIs. A GUI, a GUI, is a graphical user interface. An API is an application programming interface. Think of a GUI is how a person interacts with a program on their computer. An API is how code talks to other code to pass data and send commands. And so whenever you are using Amazon.com in your browser, you're dealing with a GUI, and that GUI is then sending requests and getting responses across the internet. What's usually happening when you're using an app, though, on the phone, is you're using a GUI, but then it will make a request and talk to the API, which doesn't pass back a GUI. It'll go talk to Amazon or Twitter's API, and it'll just pass back the data. And that data will go across the internet like everything else. Now, in terms of mobile UI, I won't say much. iOS has a kit that you can build, get a Mac, download Xcode, use that, use Swift or C or Objective-C, and you can build interfaces. You can build native apps that way. For Android, which I've done iOS development, haven't really done Android. But it's similar. You'll get something like Android Studio, and you will use Java, Kotlin, or something else, and you will build a native application. Now, these other ones here are for those who don't want to use those toolkits that were provided by like Apple and Google for Android. These are for people who like, hey, I want to use different languages. If you want to do it in Ruby, then obviously maybe something like Dragon Ruby. Now Flutter is another one that you can do. Now Flutter, I believe it uses Dart. And so this was just a different programming language. It didn't show up over here, but it's a programming language. Xamarin, what's that? Well, C# React Native, what's that? Well, that's actually JavaScript. JavaScript using React to create apps that you can sell in the App Store. So this is mobile web development. It's different toolkits, sometimes different languages, sometimes not different languages to build apps. All right, other common random web stuff. Node.js, I mentioned this earlier. Node.js is something for running JavaScript outside of a browser. You just think of it that way. It's really commonly used for web development for the back end and for tooling as well. So it's something I've used quite a bit. AWS and Azure, these are not the same kind of web stuff. What is AWS and Azure? Well, if you're a developer, you can go out to some place and you can rent a computer, essentially. Or you could buy a computer and get it on the network so that it can be on the internet. Or you can rent a computer from somebody else so it's on the network. Like you can go to DigitalOcean and get a computer, get a server. Is really the best way to say it. Get a server here, and it's going to get connected to the internet, and you can build stuff that way. What AWS and Azure are think of them as large services for servers. So AWS is actually run by Amazon. Amazon Web Services is what it stands for. Azure is something that's done by Microsoft. AWS and Azure are servers that you can essentially go pay for and say, you know what, I don't have time to set up my own infrastructure. I don't have time to go set up a bunch of computers somewhere and hook them up to the internet. I just want to go and I want to rent 1,000 servers and run a website on it. That's what Azure and AWS are really good at. They're fun. I use AWS, but they're both very capable. They also can be expensive sometimes, but it's great and fun technology. But think of them as, instead of putting your own servers on the internet, you can go there and say, okay, create me a Linux server, create me a Windows server, and you can start doing development that way. So that covers these two left columns. Now let's talk about databases before we move on and cover some of our last terms. And some of these just don't really fit very well, but they come up commonly, so I wanted to bring them up. Databases. So databases, they come in different flavors. Now there's things called relational databases. These top three are all what are called relational databases. They all basically work the same way. Not exactly, because then there would be no difference. There are differences, but they basically work under the same paradigm. Think of think of relational databases as a bunch of Excel spreadsheets that you can join really easily. I think it's a good mental image for it. So databases come in that flavor, but they also come in others, like DynamoDB or MongoDB. MongoDB is a document database. Think of it as storing blobs of data in a database as opposed to Excel spreadsheets. You know what? It's kind of hard to explain. You'd really just need to learn how to program and go mess with it. Really what they are, they're just different ways of storing data. But it's not just a preference thing here sometimes. Sometimes it is. Often how you store the data really changes how you can work with it efficiently. And so sometimes it's best to use relational databases for things. Sometimes it's best to use like a document database or Elasticsearch. I love Elasticsearch. Sometimes it's best to use those tools because the problem you're trying to solve is better solved in these kinds of databases. So as a back-end development nerd, what you would do is you would not only learn your languages, but you will also learn your databases. You don't have to learn them all. You'll start with one probably, and you'll learn how to use it. And then you'll learn how to use this other different type of database. Going from SQL Server to Postgres, it's super easy because they're all basically they're essentially the same. But going from SQL Server to MongoDB or Elasticsearch, well, they're actually very different. And so you have to change the way you think about how you store the data and how you get it if you switch between those. But that's something, as you get more into backend development, that's something you would end up doing. Now, other random stuff that I just thought I would throw in because these things come up a lot. Let's start down here at the bottom with this full stack developer. Often with code schools or job applications and whatnot, people say we're looking for a full stack developer. What do they mean when they do that? Usually when somebody says, I'm looking for a full stack developer, they are looking for somebody who can do front-end development and they can do back-end development. That doesn't necessarily mean they'll be just as good at front-end as back-end, but that's generally what they mean. And usually when people use it, they're talking about web front-end. I really think you can apply it just as well to mobile development down here, because web front-end is just a different way of doing front-ends than mobile. But that's a full stack developer. A full stack developer is someone who can work on both sides of this divide. And some developers really don't want to do that. Some developers just want to do front end and build user interfaces. And some developers just want to do back end. But a lot of places really need full stack developers because you can solve. Sometimes you know better how to solve problems if you know both sides of the thing and how they both work. That's a full stack developer. So next time you see a code camp who's talking about it, that's what they're talking. You're going to be learning JavaScript, HTML, CSS, and then some back-end language and framework to go along with that. Operating system, like Windows, and Mac OS, and Linux. Essentially, the job of operating systems is to give an environment for apps to run and also provide common systems for talking to devices like hard drives and all that. So that's what operating systems do here. What about Docker? Docker, I only mention this because it's a very commonly talked about term. It's one of the crazy popular ones right now. What is Docker? Docker is basically a different way of running. It's a different way of defining what's running in your backend computers. I would really want to say it that way. So let's say you wanted to set up a server with ASP.NET, right? Well, you could log into a server and you could go in and install a bunch of stuff. Or you could use Docker, and then Docker can be used with other services. It's really mostly on the back-end side of things is what that's for. It's interesting and it's not a beginner topic, and so we won't get into it. Git and GitHub. Is there a difference between these two? And the answer is yes. So programmers work on code source files. These are just plain text files. These are not something you see in Word. You don't use Word for this. Use something like Atom, or use something like Visual Studio Code, or Xcode, or Vim, or something like that to change your code files. Well, those code files need to be stored somewhere. And not only stored somewhere, they need to be versioned, meaning you need to be able to revert, if you break something, be able to revert to an old version of that file. That's what Git's for. Git is a version control system. So when somebody talks about version control, what they're talking about is that ability to keep track of all the different versions, but also these are at the center of having lots of developers work together, these version control systems, because these developers have to keep all this code in sync. So super important to Git these days being the most popular one. Now GitHub is a website that allows you to store GitHub repositories on it and helps you collaborate with other developers. So GitHub is built to use with GitHub, but you can use Git without using GitHub. Trello and Jira, these work together. If you work in a business context, then you already know what these are probably. Basically, this is where product owners create work items for developers to work on. They're for organizing units of work. That's essentially what they do. WordPress. WordPress runs a significant portion of the internet. What is it? Well, WordPress is actually written, or at least was originally written in PHP. It's a blog. It's a content management system for the web, but it uses this language over here on the left, PHP. What is data science? Well, if we think about our internet and we go back to this back end, these databases tend to accumulate a great deal of data, whether this is relational databases, DynamoDB, whatever. These will tend to create lots and lots and lots of data. Data science, which is not something I do, is all about taking data, figuring stuff out, and of course, obviously, therefore knowing stuff or doing things in response to that data. Like, for example, if you have somebody signing up for your service and they're giving you 100 pieces of data to sign up for your service, well, you can use some stuff in that general realm of data science to take a look at all of that information, figure out, okay, what's the best way to get them to give us money for selling my widget. You could use some machine learning for something like that. That whole data science world is not one that I live in, but it is one that is on the back end side of things. That's all I really wanted to say about that. What about Apache and Nginx? Well, Apache and Nginx, and at this point it's random because it is just random technologies. What happens is when a request comes into a server, something in the server needs to basically, you need a general tool for taking requests and then routing them to the right programs or routing them to the right things on the server. That is where Apache and Nginx live. Or if you're in the Windows world, IIS, Internet Information Services. And so that's what they do. And so when I was a .NET developer, I learned IIS to go with my C# and my ASP.NET and my SQL Server. That was a part of the stack, this back-end stack that I had to learn. Right now at work, I'm using Apache because I'm running on a Linux machine. I'm not running on a Windows machine, and using that with my back-end technologies that I'm using right now. So that's what they're for. And then finally, the very last term, Agile. How does Agile fit into this? And it really doesn't, actually. Agile is, once again, another thing mentioned because it's a buzzword. Agile is a set of principles on how to do development, how to organize a bunch of developers, or maybe not organize is the right way, how to think about coding together as developers. It's principles for that. There's types of Agile frameworks, like extreme programming, that take those principles and apply them in different ways. There's Scrum, that's a really popular one, right? That apply those principles in different ways of getting developers to work together. But it's not a technology. You can use Agile when developing Agile principles, Scrum, extreme programming, lean programming, whatever. You can use those principles to do any sort of programming work in any of these technologies. Okay, so that was a lot of information. If you actually made it through this whole thing, then congratulations, you did it. If you have any questions about any of this, please leave comments below. If I get some questions, and if they're questions I can answer, I'll make a follow-up video and post those answers. So hope you found this useful. If you have any other requests for topics, you can always put that in the comments as well. Thanks for coming.